Okay, so for question 2, I've collected together eight quick questions. So get ready to press pause before you decide on what your answer is going to be. So the first one is, which is the correct diagram for shear stress? A choice of A, B, or C. Press pause when you've decided to reveal the answer. So you should have chosen C. What is the symbol commonly used for shear strain? Shear strain. Okay. Press pause when you decided. Press play. Shear strain is the sort of gamma looking symbol. What is the correct formula for shear strain? Okay, so that's the term that's going to give me a ratio of 2 lengths. So, got a diagram there. We've got a D and an S. The shear strain term is here. You can see that. It's also is the same as the angle, provided we're working in radians. Got height and the length of the thing that we're trying to pull. Which formula do we want to use? Press pause when you've decided. Press play. Hopefully you chose B. What is the correct formula for modulus of rigidity, also known as the shear modulus? 3 choices. Pause the video, and when you're ready, press play. Hopefully you went for A this time. What is the shear stress value here? So you've got a sort of T-junction thing here has been glued to the bottom, and we want to know what the shear stress is on this top section. So various options to work out your calculation. Hopefully it's straightforward. Press pause. When you got an answer, press play. And then hopefully you would have gone for 250 kilopascals. So you want to take this area section, this top area section, and get the force and divide that by that. Make sure your millimeters has been converted into meters and you should be okay. We're in kilonewtons here. Everything's kilo. So you might want to use 4 divided by, what would that be, 0.08 and 0.2. Write out the polar second area of moment formula in integral form. So watch out, it's an integral form. What could that be? Okay. Pause the video, have a think about it, write it out, and when you're ready, press play. Thing is here, we're asking for the integral form, so we're actually asking kind of for the fundamental definition for the polar second moment of area. And that's going to be, it's the integral of the R variable squared over its area. You could have written, instead of integral over area, you could have written it out in the form of delta x delta y, but you're going to want to switch to polar coordinates, so dA is probably more sensible. I suppose you could also start doing that, where you could go to pi, so that's a circle, and then that would be your little sliver of area that you're going to integrate by in polar coordinates. So these are other possible solutions. What is the equation of polar second moment area for a solid shaft? Look it up in your formula booklet if you don't know. And when you're ready, Press play. And you should have gone for A. No, you shouldn't have done. You should have gone for C. Okay, always good to make a mistake on the final answer to show everyone's human.